physical science or ninth grade. I wanted to help you out with Bohr models since it might seem a little complicated, but it's really not. So I don't know if you've seen Bohr models before, but Bohr models are just basically a way to visualize an atom and its electrons based on the energy levels that they have. Okay, and I talked about how there are certain number of electrons that go into every shell. Okay, so I had an example on the assignment from nitrogen. What I wanted to do is do a bigger element so that you could see what that one looks like. Okay, so I want to do selenium. So if we find selenium on our periodic table, we see it right here. It's number 34. So first of all, our instructions say to number 1, find your element and its symbol, which is Se. So I'm going to try and do this over here in Paint. Let's see. So our first thing is to write down the element. Okay. And selenium is number 34. I'm going to write that down over here just so that I remember that. And that's, one of the main things I'll need. I can come back to that periodic table if I need it. Okay. So right now, selenium we have as our center one. 34 is its atomic number, which means this is how many protons and electrons it has. Okay, it's 34. So what we have to do next is look at making our orbitals for selenium. And it says in our instructions to take a look at our periodic table and count the row till we get to the row of our element. So selenium is in row, let's see, let's count down. 1, 2, 3, 4. Selenium is in row 4, which means it has 4 energy shells. Okay, it has 4 orbits. So you can draw your orbits around your element. So 1, 2, 3, 4. Now notice I'm making these a little on the closer together side just because I want to try and get it all on one space for you to see. Now, normally when you're drawing this, you want to give yourself plenty of space to be able to look at and count your number of electrons. Okay, I'm going to move my 34 down here. And then I also want to put down something else, which is our instructions that we've kind of already followed. So 1, well, not the instructions necessarily, but I wanted to put down the max number of electrons in each shell. Let's make that smaller. Let's make that like 20. Okay. So underline that. And so, as it says on the assignment, your first shell, the max is 2. Your second shell, the max is 8. For your third, the max is 18. For your fourth, it's 32. Now fourth and up is 32. On your assignment, I kind of put a little notification on there, like a little note in the stars. This is what we normally see from fourth and up. Technically, there is a theoretical maximum for 5 through 7, but I'm not going to include that because we'll talk about that more if you actually take chemistry. And that has to do with like orbitals, which is something entirely different, but we're not really going to talk about that, okay? And then finally, the last shell, no matter what, is the max is 8. Okay, so let's take a look here at selenium. Our next thing we have to do to make our Bohr model is to start putting dots on our orbitals starting from the first or like the innermost and going out, making sure to follow the rules here on this list. So I'm going to take my pencil and I'm going to choose a really like large brush size so we can see my dots pretty well when I draw them. Let's make them red so you can see them. So selenium has 34 total electrons. So we have to start adding up to 30. We have to add 34 dots onto our diagram following these rules. So first is obviously pretty easy, is 2. So you put 2 electrons in your first shell. That's done. Your second has to have 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now I can put 8 because there's a total that I've put on here is 10 so far. I have to get to 34. So my second one is done. Okay. Let's see if I can't switch to a... Well, I'm just seeing if I can't have a better brush here real quick, folks. Nope. Not gonna do it for me. Okay, whatever. Third one is 18. So we'd put 18 on there. I'm gonna pause real quick and do that because it's gonna be a pain otherwise to watch me do it. So just a sec. And 18. Okay, so I got 18 in there, and you might be, and I still can put that because we had 2 before, then we added 8. If I add 18, that's only 28. I still have 6 left to place. So that third row is done. Now the fourth, it says, goes up to 32, but we're in our last shell here, so we can't go over 8. But that's okay because we only have 6 to place, right? 6. So in this last shell, you place those last 6. 1, 2, 3, 4, 5, 6. And now I kind of put them in weird areas, and like I try and pair them up by 2s to make them easier to count. But that would be a basic Bohr model of selenium. Okay, just going from the inside out, filling in electrons based on the maximum number of electrons you can have in each shell, going 2, then 8, 18, 32, whatever, outward. As long as your last shell is within 8, you're good. Again, this is different. This is a generalization of how it works, and yeah, but this is how you would make one. I can do another one if you want. Just give me a second to set up here. Okay, so let's do another one from the periodic table. We can do one that's smaller than selenium. What about if we do something like, I don't know, magnesium? Magnesium is over here. It's number 12. So let's put that down. It's number 12. 12. And its symbol is Mg. So let's put that here in the middle. Mg. All right, so for this one, magnesium, count the rows down, 1, 2, 3. Magnesium's in the third row, so it actually only needs 3 of these orbits. So we could actually get rid of one of them. So, nope, it's gonna be too hard. So, much faster. Okay, so magnesium has 3 orbitals, or 3 shells. It has 12 electrons in total. So we're just going to fill those in like we normally would, following our list. So the first has 2 maximum, 1, 2. This one can have 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice I have 8 in this middle, in this second circle. So we've got 10 so far, and we have 2 left over. We still need to place because we got to have 12. So we just put those extra 2 in our very last one, and we follow the rule that our last shell has to be below the number 8. Okay, so this is the Bohr model for magnesium. Okay, Bohr models are pretty easy, and they just help to show you how big or how small an atom kind of is relative to, you know, its atomic number. I know in our other Bohr models, like in the other diagrams, it has the nucleus fully fleshed out, but we don't necessarily need that, since we're just trying to see electron level and how those are in the atom, because we're in bonding, and in bonding with chemicals, your electrons are a big key player. So we're kind of focusing on our electron count right now. Okay, so Bohr model, follow these for the number that goes in each ring, and just fill in your number of electrons from in, out, following those. Okay? All right. Let me know if you have any other questions, and I'd be happy to help. Okie doke. Bye for now.